far beyond the familiar blue skies of Earth, in the frozen and distant regions of our solar system, exists a planet that challenges the very laws of planetary behavior. This is Uranus, a planet so bizarre that its very existence defies the norms of planetary dynamics. Unlike Earth and the other planets in our solar system, Uranus spins in a way that no other world does. It's not just tilted, it's knocked over onto its side, its axis at a mind-boggling 98 degrees. This extreme tilt has baffled astronomers for centuries, and even today, it stands as one of the most perplexing phenomena in the cosmos. But how did this happen? What forces shaped this icy giant to behave in such an unusual manner? To answer that question, we need to journey deep into the history of the solar system, to a time when chaos reigned and planetary formation was an ongoing battle between cosmic bodies. Uranus may seem like a distant, cold planet, hidden far away from our everyday gaze, but it offers us a fascinating look into the unpredictable processes that governed the early solar system. As an ice giant, Uranus is fundamentally different from the larger gas giants like Jupiter and Saturn. Its composition is made up largely of water, ammonia, and methane, substances often found in the icy outer reaches of the solar system. Its blue-green hue comes from the methane in its atmosphere, which absorbs red light and reflects blue light. But despite its icy appearance, Uranus holds one of the most mind-boggling characteristics of any planet: an axis that's tipped almost completely sideways. The poles of Uranus aren't slightly tilted as we find on Earth. No, they're nearly aligned with the planet's orbital plane, and for half of its orbit, one pole is directly facing the Sun, while the other is in eternal darkness. This dramatic axial tilt has profound effects, and Uranus experiences extreme seasons that span entire decades. Earth's tilt causes our seasons, but our year is just a fraction of the time it takes for Uranus to complete one full orbit around the Sun. In fact, Uranus takes approximately 84 Earth years to complete one orbit. With its tilt, each of Uranus's poles faces the Sun for about 21 years at a time, basking in sunlight for that long, while the other pole remains shrouded in complete darkness. After 21 years, the planet completes half of its orbit, and the poles switch places, so the former dark pole is suddenly illuminated, while the once sunlit pole is now plunged into darkness. The effects of this long, drawn-out cycle on Uranus's atmosphere, weather patterns, and even its geology are nothing short of extraordinary. This phenomenon isn't just a fascinating quirk. Uranus's extreme tilt affects everything about the planet. Imagine the sheer scale of its seasons. While Earth's seasons last only a few months, Uranus's seasons stretch on for decades. The planet's weather systems experience dramatic shifts, with large-scale atmospheric movements, high-speed winds, and possibly even violent storms that last for years. The polar regions, when they face the Sun, heat up, possibly causing dramatic weather patterns. But when plunged into darkness, temperatures plummet to freezing depths. This has profound implications for our understanding of planetary dynamics and climate. Uranus's extreme tilt provides a unique laboratory for studying how axial tilt can reshape an entire planet's behavior. Now, the question arises: how did Uranus end up with such a strange and extreme tilt? The answer lies in the early chaos of the solar system, where the planets were formed in violent conditions, colliding and merging in unpredictable ways. At the time of Uranus's formation, the solar system was not the peaceful, stable place we know today. It was a time of immense disruption, with planetesimals, large chunks of rock and ice, racing through space and colliding with one another. Some of these collisions were so violent that they reshaped entire planets, leaving deep marks on their structure and behavior. And this is where the mystery of Uranus begins. One of the most widely accepted theories is that Uranus was struck by a massive object, possibly a protoplanet, one of the early building blocks of the solar system. This impact, so violent in nature, knocked Uranus onto its side. The force of the collision was so intense that it altered the planet's rotational axis, pushing it to nearly 98 degrees, causing it to spin almost like a rolling ball instead of an upright sphere. The impact was so powerful that it also had lasting effects on Uranus's magnetic field. Unlike Earth's magnetic field, which is relatively aligned with its axis of rotation, Uranus's magnetic field is tilted and offset from the planet's center, further supporting the idea that Uranus underwent a massive transformation early in its history. The odd magnetic field of Uranus is more than just an interesting anomaly. It offers important clues about the planet's violent past. The magnetic field is lopsided and tilted at an angle of 59 degrees from the axis of rotation, and it's also offset from the center of the planet, suggesting that whatever happened to Uranus in the past profoundly disrupted its internal structure. These clues point to a catastrophic event that likely occurred long ago, altering not just Uranus's orientation but its very core. As if the tilted axis and magnetic field weren't enough, Uranus's moons provide even more evidence of this early collision. The moons of Uranus are locked in orbits that align with the planet's equator, rather than with its poles. This is another indication that Uranus's tilt was not a gradual process. It was a result of an immense, violent force. Had Uranus been upright like most of the other planets, the moons would likely have formed or been captured in a different alignment, one more closely tied to the planet's original axis. One of Uranus's most curious moons, Miranda, shows signs of violent geological activity. Its surface is a chaotic landscape, with deep ridges, valleys, and fractured terrain. This could be a result of the tidal forces created by Uranus's extreme tilt. The moon's orbit likely experienced significant disturbances due to Uranus's shift, leading to the stretching and compression of Miranda's surface. Some scientists even speculate that Miranda may have been shattered and reassembled, a process that would explain the moon's fractured and patchwork appearance. The extreme forces at play in the Uranian system likely caused these stresses on the moons, altering their surfaces and even their orbits over time. Uranus's moons are not all fractured like Miranda, but they all show signs of disruption. Ariel, another one of Uranus's moons, features large faults and significant geological activity, indicating that it too may have been subjected to tidal forces as a result of Uranus's extreme tilt. Umbriel, another of Uranus's moons, is much less geologically active, but it still provides evidence of ancient impacts, with craters and scars scattered across its surface. It's clear that the moons of Uranus, much like the planet itself, have been shaped by the violent forces that acted upon them during the planet's early history. Uranus's tilt also affects its atmosphere in ways that are still not fully understood. With its extreme seasonal shifts, the atmosphere of Uranus experiences dramatic changes over the course of its long orbit. The planet's weather systems are driven by complex interactions between the Sun, the planet's axial tilt, and its icy composition. High-speed winds, some reaching speeds of over 500 kilometers per hour, whip around the planet's cloud tops, creating complex and unpredictable weather patterns. Some scientists have even theorized that Uranus may have large storm systems, perhaps similar to the Great Dark Spot on Neptune, but due to the planet's tilt, these storms could last much longer, possibly decades at a time. The true extent of Uranus's atmospheric dynamics remains one of the planet's greatest mysteries. While scientists have gathered some data from the Voyager 2 spacecraft, which passed by Uranus in 1986, the planet is still far from fully understood. Its distance, almost 2 billion miles from Earth, makes it incredibly difficult to study in detail, but future missions to the outer solar system may one day unlock the secrets of Uranus's strange, icy atmosphere.